All right, so for today, you got a little high there. Geometry, we're doing 6.5 trapezoids and kites. We have lots of really great information. So first, our objectives are we're going to verify and apply properties of trapezoids and kites. And 2, we're going to determine whether a quadrilateral is a trapezoid or a kite. So first up, some things about trapezoids. Like Caden said, I wrote a paragraph because there's a lot of things to remember that we know about trapezoids that we kind of take for granted that we know. So I want to make sure we go over them. So trapezoids have one pair of parallel sides. Those are our bases. So what are our bases in trapezoid let's see, HI, JK? HI and KJ. Okay, those are the bases. Good. They have a pair of sides that are not parallel. Those are our legs. What are the legs? KH and JI. Perfect. Oh, that says JH. You know, it's just a sideways I. That's what I was going for. Yep. Okay. Then the angles that share the same leg of the trapezoid are consecutive interior angles of parallel lines. This is interesting. Okay. So give me angles that share the same leg of the trapezoid. So what are two angles that share the same leg? H and J do not share the same leg. They're opposite.
Sorry,
H and I do not share the same leg. They share the same base. H and K, okay? So H and K, so angle, I'm going to put over here angle 1 and 2. Those are consecutive interior angles because they share the same leg. Our leg is here, right? It's this parallel line, or this is here. What it's saying is they are consecutive interior angles of parallel lines. So if we look, our parallel line, if we extended this out, and we extended this out, our parallel lines, okay, we have consecutive interior angles and are therefore supplementary. So angle 1 and 2 are supplementary. Or we're going to say, so angle H plus angle K equals 180. What's our other consecutive interior angles? What's the other set? I and J. Okay, so angle I plus angle J is also, okay, but it has to be that they share the leg because the leg is the transversal that goes between the parallel lines.
So would angle K and angle J be congruent and angle H and angle I congruent?
Not always.
In an
isosceles trapezoid, yes. Okay. So then we have angles that share the same base are just base angles. They don't have anything special about them. But what are the base angles? They share the same base. H and I, okay. So angle H and angle I are base angles. Angle K and angle J. Awesome. Those are base angles. Good. Then the last one. If the legs are congruent, then it is an isosceles trapezoid. So is this one an isosceles trapezoid? Yes, the legs are congruent, right? So that right there. The legs are congruent, so this is isosceles trapezoid. Definitely an isosceles trapezoid. So there's a lot of stuff that we can know about trapezoids. You might have. Oh. Oh, right, because you guys have PE 4th hour. All right, so then let's look at the trapezoid theorems. The base angles of an isosceles trapezoid are congruent. Ooh, wasn't that the question you just asked?
What?
The base angles of an isosceles trapezoid are congruent. Didn't you just ask that? Yeah, and we said yes. Okay. In your dreams. Okay, this is true. I should have used the word nightmare. If a trapezoid has one pair of congruent base angles, okay, so if it has one pair of congruent base angles, then it is isosceles. You got it. So we're proving, if we can prove it has a congruent pair of base angles, then we can say it's isosceles. We're going to use, that's how we use them in the proofs. Okay, next one. A trapezoid is isosceles if and only if. Remember, this if and only if you might see as IFF in your notes, like in your book or different places. No, because we learned about conditionals, biconditionals, and all those things so that we could apply them to the theorems. Yeah. Mm-hmm. Yeah. Theorology. I like it. So a trapezoid is isosceles if and only if its diagonals are congruent. Okay, so this time, oh, we've got diagonals that are congruent. So there's the drawing here. So we've got KH is equal to JI. If and only if, so this is the other thing. What's different about this if and only if symbol?
Oh, it's got the little.
It has arrows on both sides, right? When it has the arrows on both sides, it's the if and only if. So this is that biconditional. You can use that to prove it either way. So if and only if the diagonal KI is congruent to the diagonal JH. So if you can prove the diagonals are congruent, then you can prove that the trapezoid is isosceles. If the trapezoid is isosceles, you can use the same theorem to say that the diagonals are congruent. Okay, this one you can use either way. All right, then we have the trapezoid mid-segment theorem. Do you remember we did the triangle mid-segment theorem?
Yeah.
Okay, so trapezoid mid-segment theorem says the mid-segment of a trapezoid is parallel to the bases. Okay, so where's the mid-segment in this trapezoid?
The middle line.
The middle line. What's the name of the mid-segment?
The mid-segment.
What's the name of it? What's the name of the... No. MN. That's L. That's the length of the mid-segment. So our mid-segment is MN here.
It looks like a 1.
Okay, and its length is the average of the lengths of the bases. So we're going to take base 1 plus base 2 and divide them by 2 to get the length.
So you do a midpoint line.
Oh, okay. Oh, gotcha. You're good. Apparently. Okay. So if we wanted to know, let's say the base here is 3 and the base here is 5. How would we find the length of our mid-segment?
You would do 5 plus 3 divided by 2.
Yeah, we would do 5 plus 3 divided by 2. What's 5 plus 3? 8. So 8 divided by 2 equals 4. So our mid-segment would be 4. Now the nice thing about the trapezoid is there's only one mid-segment in the trapezoid. In the triangle there were 3. Remember it was parallel, but it was over here, and so we made like another smaller triangle inside. Now we just made 2 trapezoids, you're right. So we could technically find another mid-segment of the smaller trapezoids, but it's not of the original.
You could technically have.
Technically no, because it would be a mid-segment of the new trapezoid.
But you'd still have
No, because the mid-segment has to go between the midpoint of the trapezoid. So once you cut this into 2 separate trapezoids, no. But then that's a new trapezoid.
Yeah, but you're still finding midpoints.
But you're finding the mid-segment of the new trapezoid.
Yeah, but it's still
Of the new
so you
trapezoid.
have infinite mid-segments.
Of infinite number of trapezoids, yes. Okay. Also, the mid-segment is also called the median sometimes. So if you see the word median, it's the same thing. Don't let that throw you for a loop. Okay, so let's actually apply these in some examples. So example 2, find each measure in isosceles trapezoid ABCD where the measure of angle ABC equals 125 degrees, AC equals 7x, and BD equals 4x plus 12. Okay, how'd you get BAD equals 120? So
Because
hold on, let's see. ABC, I'm going to label this ABC is 125. Okay.
so you have that.
BAD, uh-huh.
Is it an isosceles trapezoid?
It does say it's isosceles.
So then it equals 125.
Okay, so why does it equal 125? Okay, what was the theorem what was one of the theorems on the front side that we just read that said it? Okay, so what theorem was that? Okay, so we could say 651 if we wanted, or yes, base angles of isosceles trapezoid, right, it doesn't have an F in it, are congruent. Yes. Okay, so yeah, some of them don't have a name. The diagonals don't bisect the angles? No, we don't have a theorem that says that, right? Yeah.
Because then the two angles on D would have to, that one equals 35, but the other one would have to equal 25. The other angle for D.
Oh, okay.
So
Well,
ADB equals, ADB equals 25. Right?
ADB equals 25. How do you get that? So let's go to B, like it's next in line, ADC, right? Because it's that whole ADC is this whole angle in here.
Equals 75.
How would it equal 75?
Because A equals 125, and then in total they would equal 180.
So 125 plus 75 equals 180?
No.
Okay.
55?
There you go. Okay, so he said it equals 55 degrees because what do we know about angles? Let's see, BAD, so angle BAD. So what do we know about this angle and angle ADC? So these two. They're okay. So because they're those consecutive interior angles, right? Because it was they share a leg. Okay, so they share a leg. So they're consecutive interior angles that share a leg. Sum to 180. So we could do 180 minus 125, which is 55 degrees. Perfect. All right, so how about angle ADB, but we're not looking for ADB anyway. Okay, yes, so ADB would equal 25 degrees, right? ADB, because if the whole thing is 55 and this little piece is 30, then that little piece would be 25. That would be correct. But we are asking about ABD. So would that help you with ABD? How are we going to find ABD?
I don't know.
Okay.
So,
I like it. Don't get testy. So ABD, right, is this little angle in here.
So the diagonals don't bisect angles, right?
Right. We don't have any theorems that says it does. Okay, don't forget that AB, I'm going to extend these. All right. Don't forget that these are parallel lines. Thank you. It's true. And this is a transversal.
But that doesn't work.
That doesn't bisect, but we know things about parallel lines and transversals.
You can't. So would it equal 30 degrees?
Why would it equal 30 degrees?
Alternate interior angles?
Yes!
But
Yes!
but then...
Okay, because this angle, angle ABD, is an alternate interior angle to angle 30.
But the other angle isn't alternate interior, so that... I don't know how that works. That's what I'm confused about. Because the other part of that angle aren't congruent.
Right. Okay, but this part of the angle from the transversal to the parallel line would be congruent. So you're right, it doesn't, we can't make, like 125 doesn't relate to the other angles. Okay, because they're not alternate interior.
So basically,
or alternate.
The exterior angle of B
so let
would
me
equal 30 degrees, and the exterior angle of D would equal 125 degrees?
Yes.
Okay.
Yes. So I'm going to erase those. We don't need them if they would erase. Okay. Okay. Good. So again, it's like all the different ways. It's like mind-blowing to think about how many different ways you can like look at the shape and view it and keep looking at it and reanalyzing it and pulling out all this old information. Okay, so how about the measure of angle ACD? I need a different color. Let's go with blue. ACD. Okay, so that's this one here.
No.
Hold on, sorry, my bad. ACD, thank you. ACD would be this one here.
Your turn.
I like it, pass.
You can't pass. Nope, no passing, no skipping, no rotating, nothing. Card stuck on you and only you. Nope.
Well, I mean, and here's the thing. We have a lot of information.
Doesn't seem like we have the information we need.
Okay, but if we look, so we've got A, B, C, D. Let's see.
Wait a minute.
Okay, so angle BAD, so this is 125. B is... Okay. Okay, so D and C both equal 30. Well, you're on the right track. Your reasoning isn't quite there. But, so let's see, ADC, we know this one's 55.
Angle D and angle C are
And it is isosceles, right? So we know these are equal. So the base angles are equal. So this is 55. Okay. So you are right, Lucas, that it's 30 degrees. I'm just curious how you can get a little bit more to the 30 degrees. Because it's not so much.
Oh, it's Coach.
Why'd you say it was 30 degrees?
Because he was telling you that the bases were...
Right. So that's where we could get the 55 from.
Why is it 30 degrees, not 25 degrees?
Which would be 25.
Because that's the other angle. That's the angle. Is it
EC. Yeah. It could. So, like, let me do this. So you're saying it's 30. So what if we look at this triangle? Okay, so we're trying to get this angle here. All right. What's its relationship to this triangle? The orange doesn't show up very well. Where we're looking at this angle. They don't bisect. What can you tell me about those two triangles? They're both the same. They're congruent triangles. Okay. So because we've done all their angle measurements. Those are congruent triangles. So it is 30. So it's kind of like by CPCTC almost, right? That we can say, well, this angle here is the same as this angle because we've proven the angle, different angles are congruent, the side lengths, right? Because they share two sides. Well, actually, it would be side, side, side would probably be a better one because they share two side lengths. They share this side length, and we know the diagonals are congruent because it's an isosceles, and we know the legs are congruent because it's isosceles. So yeah, we have 30 degrees because of, we'll say, side, side, side congruence. Okay, making progress. E equals 30? AED? Okay. I'm going to have to erase all these. We have just too much stuff. You needed those? I'm sorry. I can undo it. I'm going to undo my erase. So let's go this.
So,
Let me erase these orange and... How about that? Okay.
that works.
All right.
So,
So then I can say 30 degrees and it's... Yikes. Side, side, side congruence. All right. So AED.
for 30, but I can figure out how to find the actual measurement.
Okay. So AED. So we're looking in here at this one.
Yeah. So, go to the like the BEC triangle. Okay?
So
So
the BEC triangle.
Okay. So, the angle B in that triangle equals 95 because you already know that the other angle for B equals 30.
Okay, because you know, so this one's 30, this one's 95. Okay.
And then you know that the other angle for C is 25.
ACD.
BC.
Okay. So you know this because we know this one's 30, right?
Yes.
So we know this one's 25.
So you just add those, you get 120, and then so you get 40 for E, and then since it's vertical angle theorem, you get that for the other one too.
Okay. So he's saying if we add 95 and 25, and then like this one would be X, we'd get 180. So X equals 95 and 25 was 120. So that's X equals 60 degrees. And that's the opposite angle. So opposite angles are congruent. So this one equals 60 degrees. Excellent. Woo! I like that clap. It's a fun clap. Lucas was applauding you. All right, how about F? The length of AC. Oh, but see, they gave us some good stuff up here. They said AC equals 7x and BD equals 4. We forgot, right? Like we didn't use any of them. And BD equals 4x plus 12.
So 7x equals 4x plus 12.
Awesome.
So X equals 4.
Well, I would subtract 4x first. Right, so then we'd have 3x equals 12. Then what will we do? Divide by 3. So x does equal 4. But then what's the length of AC then?
AC would equal 28.
All right, so we would have to do AC equals 7 times 4, which equals 28. Very nice, very nice. Whew. Right? We thought proofs were rough.
I didn't write anything.
That's scary. Okay. Okay. And then I think looking at the time and things, let's get through example 3, and then we'll hold off on the kites until, would you rather do a proof day on Monday or a proof day tomorrow? Okay, that's kind of what I was leaning towards. So we'll do proofs tomorrow in class, and then Monday we'll come back to the kites, okay, and finish this up. So let's do example 3. I'm going to clear it.
I have everything written down, so we can just go.
Okay, perfect. All right, so let's look at this one. Find PQ and SR if PQ equals the quantity 4R plus 2 centimeters. SR equals 2r centimeters, and mn equals 10 centimeters. So this one's much easier, right? We want to know PQ and SR, but we know PQ is 4r plus 2. Huh? Okay, so let's look. Let me just label it. So we got 2r here, and mn is 10 centimeters. So 10. So what would we do? Because what is mn? Give me a name. Define mn for me. Median. I will take median, or I'll take mid-segment, not midpoint. Okay?
4r plus 2
Does not equal 2r, because those aren't equal. Right, what do we know about the mid-segment? How do we get the...
Equals 4r plus 2 plus 2r divided by 2.
What? Why would you do 10 yet? On the front page you didn't do the... We're finding different things like
Okay, so on the front, remember it said the length of the mid-segment, LM, equal, well, let me go over here. The length of the mid-segment equals base 1 plus base 2 divided by 2.
So that's what I was trying to do.
Okay, and I would say that's what you were trying to do. Okay, so let's finish it. So we've got base 1 is 4r plus 2 plus 2r, so this is that quantity, divided by 2 equals 10. That's why he had the 10 in there. He put the 10 first. But we know, because we know the length of the mid-segment, so we can solve. Perfect. All right, so then how do we solve this bad boy?
Divide everything by 2. What?
It's already being divided by 2.
Yeah, just do it.
You can't. I can't do... I need to do the...
Add opposites.
You can divide by 2.
You did 6 on.
You get 2r plus
Okay.
1
Fair enough.
plus 1r.
Okay, I wouldn't have divided by 2 first, but okay. Is that what you guys want to do, is divide by 2? Are you combining like terms? What did you all say? Combine like terms. Okay, so then that would give us 6r plus 2 divided by 2 equals 10. So you want to divide each part by 2? That's what Caden was saying, was divide. So 3r plus 1, okay. Yep. Yep, because we divided by 3. All right, so if r equals 3, what we need to find the lengths then? Yeah, so PQ is going to equal, instead of it being 4r plus 2, it's going to be 4 times 3 plus 2, so 14 centimeters. Good, and SR was equal to 2r, so that's going to be 2 times 3, which is 6 centimeters. You put the 4 in from the 4r instead. I know what you did. You're good. All right. That one wasn't so bad, right? Like so much quicker than the last one. As long as we know how to use the formula. So for the homework, let's see. What did you say, 1 through 15 odd? No, because 13 is a kite. So that's not going to do you any good.
1 through 1?
No.
1 through 0.
That's a parallelogram. So 1 through 5, odd. And then, let's see, 19 through 29. 19's a kite. That's no good. 21. So 1 through 5, odd. 21. 23. Find the links. Okay, 25 is a kite. 20. I'll skip those. 30. Oh, we were stopping at 29. So let's do these for your homework. 1 through 5 odd and 21 and 23. And then tomorrow we'll have a proof day. And then Monday we'll do the kites section of this.